All right, so after we spend all of this time working with limits, we get to one of the most important questions that defines calculus. And it is, how do you find the slope of a curve? Or how do you find the rate of change of any given function? So here, if you look at just any curve, how do you find the slope of this tangent line? Or better yet, a function that we know. How do you find the slope of this curve? Because it's not constant. It varies depending on where you're at in the graph. So how do we find slope normally? Well, slope is equal to the change in y over the change in x. So what we do is, if I just zoom in on this picture, let's just take half of this curve. Let's pick 2 points. Let's call this one x, and let's call this one h. So then this would be f of x, and this would be f of x plus h. Just picking points. I can find the slope if I draw a line that connects these two. I can find the slope of this line. The slope of that line, of that secant, is just the difference in the y's over the difference in the x's, which is, well, the distance here is just or likewise, if I pick some values, it's going to be f of x minus f of c over x minus c. And this is what we're going to be using as we move forward. Now, so our secant, let's just write this out. The slope of our secant is f of x minus f of c, that's the difference in the y's, over x minus c. That's the delta y, that's my delta x. So how do you then take the average, so this is the average, how do you take the average rate of change and turn it into instantaneous? Or better yet, if we take the limit as x approaches c of f of x minus f of c over x minus c. This will give us the slope of our function. This is the slope of our tangent line. And the tangent is when we turn this secant and we move these points closer and closer and closer together until it's just the exact same point. So if we move x until it gets closer and closer and closer to c, until it is c, we get the exact slope of the tangent line. So we can find rates of change of any type of function. Building off of that, how do you write the equation of a tangent line? Well, how do you write the equation of a line? This is just point slope form. So you have y minus your y value equals m, x minus your whatever your c value is. So we're going to try a couple problems, and then we'll do a lot more in class. So example 2, find the equation of the tangent line to this graph at our point 1, 1/4. So really, what it's asking is, Find the slope at x equals 1. So what do? I want to know what the limit, the slope here, if I write m, equals the limit as x approaches 1 of f of x, and I'm going to write this out, f of x minus f of 1 over x minus 1. So now, what is f of x? F of x is just our function. So this is the limit as x approaches 1 of x squared over 4 minus, well, we know the y value. It's 1/4 over x minus 1. Now, if I plug this in, I get 0 over 0. So I have a little work to do. I can factor out the 1/4 on the top. I'm left with x squared minus 1 over x minus 1. One more quick step. I'm just going to write all the way down here the limit as x approaches 1 of 1/4 times x plus 1, x minus 1 over x minus 1. Those two cancel. Now I'm just left with the limit as x approaches 1 of 1/4 x plus 1, which if I plug this in, I get 1/4 of 1 plus 1, which is 1/2. So this is my slope. So what's the equation of my tangent line? Well, it is y minus 1/4 equals our slope times x minus 1. This is the easy part. This is the calculus part. So once we see that rates of change and slope is what we've been doing since we were freshmen, we call it a different name. So the calculus name for this goes to its definition. So let y equals f of x denote a function. C is a number inside the domain, and the derivative of f at c, we read that as f prime of c, is defined as the derivative, or f prime of c, is equal to the limit as x approaches c of f of x minus f of c over x minus c. We have done this. We know how to do derivatives if we know how to do limits. So, same question, different name. Find the derivative of f of x at 2. That is, find f prime of 2. So what it's asking you for is what is the limit as x approaches 2 of f of x minus f of 2 over x minus 2. So just to do a little algebra on the side, make sure I can do stuff right, 2 squared minus 5 times 2. This is 4 times 2, which is 8, minus 10, so that's negative 2. So let's plug this in. We know what f of x is. So that is 2x squared minus 5x minus a negative 2 over x minus 2. Now, we should be able to factor this easily and make sure we write our limit. X approaches 2. So, limit x approaches 2. If I plug that in, I get, hopefully, we can plug that in, just get a number. We get negative 2 plus 2 over we have 0 over 0. So because we have 0 over 0, we have to simplify. 0 over 0, simplify. So factor. Numbers that multiply to 4 that add to negative 5, that would be 2x minus 1 and x minus 2. Just double check. Negative times a negative gives me a positive. 4x, negative, yep, over x minus 2. Hey, everything works out. Our x minus 2's cancel out. So this is really just saying, what is the limit as x approaches 2 of 2x minus 1? Now we can just plug in our value. The derivative is saying, what's the slope? So what is the slope of that curve at 2? 2 times 2 minus 1. So our derivative at 2 is 3. Let's try another one. Find the derivative at any point. So find f prime of c, which is finding the general derivative for x squared. So what we do, just like we've normally done, x approaches c of f of x minus f of c over x minus c. Okay, so f of x is x squared minus, if I plug in c, I get c squared over x minus c. That's the limit as x approaches c. Next up, we're going to factor the top. It's the difference of two squares. It's x minus c, x plus c over x minus c. Again, that's the limit as x approaches c. My x minus c's cancel, and we're left with the limit as x approaches c of just x plus c. We can just plug this in. If I plug in c here, I get c plus c, which is 2c. So no matter what the c value is for a quadratic, the slope is always just going to be 2 times that number. That's a general form for every x squared, which is really, really powerful. So let's flip over to the last page. So the last problem for pre-calculus for this year is we're introducing instantaneous rates of change, which is the exact same thing as the derivative, which is the exact same thing as what we've been doing. Only instantaneous rates of change show up all over in science classes, especially physics and chemistry. So to find the average rate of change of a function, it's usually f of x minus f of c over x minus c. Just as a reminder, that's your secant line, which is that, or the slope of the secant line. Instantaneous rates of change is the derivative as x, so the limit as x approaches c of our function, or the slope of the tangent line. Okay, so let's see if we can answer example 5. So the volume of a right circular cone, the height is 6, the radius is r feet, is given by this formula. The volume equals 1/3 pi r squared h. So if I plug in that h, I get 2 pi r squared. So if r is changing, find the instantaneous rate of change of the volume at 3. That's a lot of words. All that's saying is, I want to know what is v prime of 3, or what is the limit as x approaches 3 of v of r minus v of 3 all over r minus 3. So let's plug it in. That's the limit as, and let's say that's r. r approaches 3 of 2 pi r squared minus, if I plug in 3, that's 9 times 2, that's 18 pi over r minus 3. So again, we want to factor the top. So this is the limit as r approaches 3 of, factor out a 2 pi, we're left with r squared minus 9 over r minus 3. So a couple more steps. R approaches 3. 2 pi on top, r plus 3, r minus 3 over r minus 3. Those cancel. So that leaves us with the limit as r approaches 3 of 2 pi times r plus 3, which just leaves us with, if I plug in 3, it's 2 pi times 3 plus 3, or that's 6. 6 times 2 is 12 pi. So at 3, the volume is changing by 12 pi. Those are derivatives. We're going to spend a lot of time next year working on these. So good luck on the homework. We'll go over any of these questions you have in class.